Imagine a world where your phone charges itself, not from a wall outlet, but from the air around you. Sound like science fiction? It's closer than you think. Scientists are tapping into a hidden source of power ions in the atmosphere. This new technology is called ion harvesting. It has the potential to provide clean, free electricity to everyone, anywhere. Ion harvesting is different from anything we've seen before. It doesn't burn fossil fuels or rely on dams. Instead, it harnesses the natural electrical charge present in the air. You might not realize it, but the air is full of tiny particles called ions. These ions are constantly on the move, creating a kind of invisible electrical current. With special devices called ion collectors, we can capture these ions and convert their energy into usable electricity. It's like fishing for electricity in the air. And the best part? It's a completely renewable resource. As long as we have an atmosphere, we'll have ions to harvest. But where does all this electrical charge in the air come from? It turns out the Earth itself is a giant electrical generator. High above us, in the upper atmosphere, there's a layer of electrically charged particles called the ionosphere. This layer is constantly interacting with the Earth's magnetic field and solar wind, creating a global electric circuit. Think of it like a giant battery, with the Earth's surface as the negative terminal and the ionosphere as the positive terminal. Between them flows a constant current of electricity carried by the ions in the air. This is the power source that ion harvesting taps into. This means that ion harvesting can work day and night, rain or shine. Unlike solar panels, which need sunlight, or wind turbines, which need wind, ion collectors can generate electricity 24/7. This makes it a potentially more reliable and consistent source of renewable energy. So how do we actually capture these invisible ions? Scientists have developed special materials that act like magnets for ions. These materials have unique properties that allow them to attract and trap ions from the air. When the ions come into contact with the material, they create a small electrical current. The efficiency of ion collectors depends on a few factors, including the material used, the design of the collector, and the local atmospheric conditions. Some of the most promising materials for ion harvesting include graphene, aerogels, and certain types of polymers. These materials are highly conductive and have a large surface area, which makes them ideal for capturing ions. As research progresses, scientists are constantly developing new and improved materials that are even more efficient at capturing ions. This means that the amount of electricity we can generate from ion harvesting is only going to increase in the future. For decades, we've relied on solar and wind power as our primary sources of renewable energy. And while these technologies have come a long way, they still have their limitations. Solar panels need sunlight, which makes them less effective at night and in cloudy conditions. Wind turbines require wind to operate, and their large blades can be hazardous to birds and other wildlife. Ion harvesting offers several advantages over these traditional renewable energy sources. First, it's available 24/7, regardless of weather conditions. Second, it has a much smaller environmental footprint, requiring no large-scale installations like solar farms or wind farms. And third, it has the potential to be much more efficient, as the air around us is teeming with electrical energy just waiting to be harnessed. Imagine a world where every building, every vehicle, even every person could generate their own clean electricity simply by harnessing the power of the air around them. This is the promise of ion harvesting, and it's a future worth getting excited about.